Assalamualaikum everyone, my name is Hena Lim. Matrix number is BB233110620. I'm here to presenting my part in our group assignment, which is part 1. Construct a appropriate graph or chart to compare the bit relative frequency and cumulative relative frequency between the two metrics, which is the number of visits and the number of purchase in e-commerce website. First, I arrange the data given in ascending order. Second, I collect the data by class and calculate the frequency for number of visits and number of purchase on e-commerce website and put the data on frequency table. After construct frequency table, I construct another table which is relative frequency table that contain midpoint and the relative frequency, number of visits, and the number of purchase. I determine the midpoint by using upper limit plus lower limit and divided by 2. For the relative frequency of the number of visits, I using a formula which is the frequency of the number of limit divided the total e-commerce website. For the number of purchase, also using the same formula, which is the frequency number of purchase divided by total e-commerce website. After calculating the midpoint and the relative frequency, we can using that data to construct a histogram. As you can see on the slide, graph number 1 is histogram for number of visits in a million. And graph number 2 is histogram for number of purchase in a million. As you can see, graph number 1, you can barely see the graph. The histogram is skewed to the right. For graph number 2, you can see clearly the number of purchase histogram is skewed to the right, which is we can conclude that both of these histogram is skewed to the right, which is positively skewed. Next, we construct another table which is cumulative relative frequency table. This table consists lower limits, upper limits, midpoint, and cumulative relative frequency for the frequency class of the number of visits and the number of purchase. After construct the cumulative frequency table, we can using upper limit data and the cumulative relative frequency data of the number of visit and the number of purchase to construct a graph. I construct a graph by using Microsoft Excel. As you can see on the slide, the graph 3 and the graph 4 is the graph for number of visit and the number of purchase. In this graph, I am using OGIF graph. Graph 3 and graph 4, which is the number of visits and the number of purchase in millions, if a increasing graph. By compare all the 4 graphs in this slide, we can conclude that the relationship between the number of visits and the number of purchase is strongly connected.
My name is Caroline Ivy Celeste. My no metric is BB233110902. I will talk about the part 2 question, which is calculate and compare measure of central location between the two metrics. So I will find 3 things in this part 2. The first one is mean, the second one is median, and the third one is mode. The definition of these 3 is the mean, known as the average, is a measure of central tendency that represents the sum of all value. It is commonly used statistical measure to summarize and understand a set of data. The second one is median. The median is a measure of central tendency that indicates the middle value in a short, ascending or descending list of numbers. The median is often used as a measure of central tendency in preference to the mean because it is not affected by outlier. And the last one is mode. The mode is the most frequent number in the set of data. It is the value that appear most often in a data. First one is the mean. In order to get the mean, you need to follow the formula and then you will get the answer. The formula is the green box on the slide. So you need to plus all the number on the data and then you need to divide by the total of number on the data and we will get the answer. So my answer for number of visit is 37.71 and my answer for number of purchase orders is 166.82. Next is a median. In order to get the median, you need to put all the numbers in order and then you need to find the middle number in the data and you will get the answer. But for this data is there are two number in the middle, so all you need to do is to plus these two number and then divide it by 2 and you will get the answer. So my answer for number of visit is 34.5 and my answer for number of purchase order is 163.9. The last one is mode. How you get the mode is you need to find the most frequent number in the data. So my answer for mode is 34.1.
Hi, I am Dracheng Shipping. My metric number is BB22110187. So to complete the part 3, first I have to apply the formula of LP to calculate the 25, 50 and 75 percentile of the number of visits. After applying the formula, I get the answer for each percentiles. But this is not the end. To get the final answer, I have calculated the 25 percentile that is located 75% of distance between 7 and 8 observation to get the last answer. And for the 50 and 75 percentiles, the calculations are the same except the different observation. After I get the final answer, I can know the 5 summary values of the data. The answer of IQR is 13.48 and there are no outliers. After all of this calculation, we are able to get the box plot that show on the right hand side of this slide. For the number of purchase orders, the calculation step for the percentiles are exactly the same as the previous slide explanation. By following the same step, I get the answer for each percentiles, 5 summary values, IQR, the outliers, and also the formation of the box plot. The distribution is positively skewed.
And today I'm going to present the part 4, which is calculate and compare measure of the dispersion between the two metrics. So in this part, this consists of 5 calculation, which is the first one is range, the second one is mean absolute deviation, which is, or we call it MAD, and the third one is variance along with standard deviation, and the last but not least is coefficient of variation, or we call it CV. So let's restart. The first calculation is range, which is the formula is maximum value minus minimum value. So as we can see in this slide, the maximum value for the number of visit is 54.2 for Shopee and minimum value is 23.0 for PG Mall. And while the number of purchase order is, the maximum value is 231.9 for Shopee and 116.5 for Signature Market. The range number of visit in million is equal to 54.2 minus 23.0 equal to 31.2, while the range number of purchase order in million is 231.9 minus 116.5 equal to 115.4. In conclusion, the range for the number of visit in million and the number of purchase order are 31.2 million and 115.4 million respectively. So let's move on to the next slide, which is mean absolute deviation, MAD. So how to find the MAD value? To find the number of the MAD is the number of x minus with 37.71, which is the number of the mean of the number of the visit from part 2 equal to the number of the x minus with x bar. So to calculate the MAD, we take the number of x minus x bar equal to 223.44 over 30, which is the total number of the company, and equal to 7.45. Next is the mean absolute deviation for the number of the purchase order, which is we use the same formula and the same technique how to find the x minus x bar. So the mean absolute deviation for the number of purchase order is 769.74 over 30 and equal to 25.66. And in conclusion, the mean absolute deviation for the number of visit in million and the number of purchase order are 7.45 millions and 25.66 millions respectively. So next slide is variance and standard deviation. So to find the total number of x minus x bar square is the total number of mean in number of purchase order at part 2 minus with the x number. To find the value of variance and standard deviation is we can use the formula of variance, which the number of x minus x bar square over n minus 1. N is referred to the total number of e-commerce website, while to find standard deviation, use the formula of square root of s square. Variance for the number of visit is 2206.98 over 30 minus 1 equal to 2206.98 over 29 and equal to 76.10. For the standard deviation, square root 76.10 equal to 8.72. To calculate the variance, we take the total number of x minus x bar square, which is 28,640.24 over 30 minus 1 equal to 28,640.24 over 29, and the final answer is 987.59. For the standard deviation, square root 987.59 equal to 31.43. In conclusion, the variance for the number of visit and the number of purchase order are 76.1 million and 987.59 million respectively. The standard deviation for the number of visit and the number of purchase order are 8.72 million and 31.43 million respectively. The last but not least of part 4 is coefficient of variation, CV. The formula for coefficient of variation is S over X value. X value refers to the total number of mean at part 2, while S refers to the final answer of standard deviation. Coefficient of variation for the number of visit is 8.72 over 37.71 and equal to 0.23. Besides, CV for the number of purchase order is 31.43 over 166.82 equal to 0.19. In conclusion, the coefficient of variance for the number of visit and the number of purchase order are 0.23 and 0.19 respectively.
Hi, I am Miss Xiuling. My number matrix is BB2211054. The question of part 5 is calculate and interpret of association between the two matrices. First, I will show the scatter plot to visualize the relationship between traffic and purchase orders. The scatter plot will reveal any patterns or trends in how the two metrics are associated. Next, the table will show the data that have been calculated. In this part should calculate the correlation coefficient between traffic and purchase orders. In the first column has shown the formula for sample covariance, and the second column shows the answer, which is 5130.363 divided by 30 minus 1 equal to 176.909. So, the final answer is a positive value.
A positive value for covariance indicates a positive linear relationship between the two variables. For other knowledge, the covariance is 0 if x and y have no linear relationship. Alright, let's go to the next calculation, which is sample correlation. In sample correlation, need to calculate the R-square value, which represents the proportion of the variance in purchase order that is predictable from the variance in traffic. Formula for the sample correlation is inside the first column. For the second column is the calculation, which is 176.909 divided by 8.27 multiplied by 31.43 equal to 0.681. So the final answer also is a positive value. It is a positive relationship. The correlation coefficient is unit free since the unit is the numerator, cancel with those in the denominator. A higher R-square value indicates a stronger linear relationship between the two matrices. That's all. Thank you.